Now, if instead of finding number of 8-letter words, what if my job was to find number of 6-letter words? That is a much harder problem to solve. We cannot apply a general formula to solve this problem. We will solve the problem by breaking it into parts. Let us first find the number of ways in which 6-letter words can be selected from 3 A's, 2 B's, 2 C's and a D. To do this, we have to split the problem into possible cases. In one case, I can have a situation where out of the 6 options I have, I fill in 3 letters of the same kind, 2 of the same kind, and the remaining one with a different letter. Such a situation is referred to as 3 are alike, 2 are alike, and 1 is different. The letters we are given can perfectly fit this situation. For the 3 alike, or to choose X ones, I can only choose the A's which are 3 in number. Please note that I cannot choose B, C or D as none of these letters are 3 in number. Hence, number of ways I can select a letter which is 3 alike is 1C1, since I have only one option for a letter which appears 3 times. Now that we have used up the A's, let us strike them out. For the 2 alikes or the X2's, I have 2 options left, B or C. I need only one set of letters which is 2 alike, hence number of ways I can select one set of the 2 alike from the given 2 sets of 2 alike is 2C1. Now my final job is to select one different letter or to select X3. Of course, one of the candidates for that is D. Actually, if you think about it, when I chose my 2 alike, I could have chosen either 2 B's or 2 C's. Let us first consider the case when I chose 2 B's. In such a case, I could have chosen the C to fill the position of one different letter. In the same way, for the case when I chose 2 C's, I could have chosen the B to fill in the position of one different letter. Hence, in either case, I get one option apart from D to choose X3. So I have two options to fill X3, thus I get 2C1 ways. Now I have to choose 3 alike and 2 alike and one different letter. Hence, the total number of selections becomes a multiplication of these three terms, which is 1C1 multiplied by 2C1 multiplied by 2C1. In another case, I can have letters such that 3 are alike and 3 are different. Again, for the 3 alike case, I can choose only A's. That gives me 1C1. Now I need 3 different letters. Of course, they will be B, C and D, 3 options for 3 positions, so 3C3 selections. Hence, total selections is 1C1 multiplied by 3C3. One more case would be 2 alike, 2 alike, 2 alike. Possible candidates for 2 alike are A, B and C. I cannot of course choose D as it is only 1 in number, so choosing 3 out of 3 can be done in 3C3 ways. One more case would be 2 alike, 2 alike, 2 different. For the 2 alike, I have 3 options, so 3C2. After filling out the 2 alike, I will be left with 2 options to fill the 2 different, hence 2C2. So finally, I get 3C2 multiplied by 2C2. Let's move to the original problem of finding the number of words. In words, we are not just concerned about the selection of letters but their arrangements as well. Let's start with finding out the number of ways in which the first set of letters can be arranged. We will use the formula which we derived earlier for arranging n objects, of which p are alike, q are alike, r are alike. We have 6 objects, so we get 6 factorial. But 3 are alike and 2 are alike. So we divide the expression by 2 factorial, 3 factorial. Similarly, for the second case, we multiply by 6 factorial and divide by 3 factorial for 3 alike objects. You can see for yourself that for the third case, the expression would be 6 factorial divided by 2 factorial, 2 factorial, 2 factorial, and for the fourth case, the expression would be 6 factorial divided by 2 factorial, 2 factorial. Total number of arrangements would be the sum of all the arrangements for each case and will be given by this expression.